Then we're going to study problems on speed, distance, time. Okay. So first of all, let's recall the definition of the speed. Recall the definition of speed, then find the relationship among them. Okay, what is speed? Okay, speed is going to be the distance it travels and the time you're going to spend on the road. Okay, that's the relationship. So we simply write S equals D over T. Okay. So if you know the distance, you know how much time you spend, then you do the division. Then you get a speed. Okay. But sometimes if you know the other two, you can determine the third quantity. So S equals dt, right? If you multiply both sides by t, right? So you get S t equals, right? You multiply by, right? S equals t equals d. So if you know the speed, if you know the time, you can also find the distance it travels. For example, the car, it takes the speed of the car is 60 miles per hour, and how much it travels in 2 hours, right? So it's 60 times 2. Okay. And you can also find the time switch between S and T. So T can be D divided by S. Okay. So that means that the time is going to be, that's a little bit more difficult to understand. The time is going to be distance divided by speed. Okay, the time is going to be distance by speed. So basically, you have three formulas. Let me move the formula down here. So you have these three formulas you're going to use. Okay, and you can derive one from another. Okay, so you look at ST equals D, then both sides you divide by S, then you get a T equals D over S, right? And then, if you divide by T, and you can get the third one. So speed times time equals distance. You can begin with that. Okay. So I'll give you an example. Here's the example. Right. Well, if it travels this is distance, D equals 2,000 kilometers, and it takes 4 hours, right, to travel from 2,000 kilometers, right? The speed is going to be 2,000 divided by 4, right? So it's a 500 kilometers per hour. Okay, that's a speed. That's a speed. Now, if you know the speed, here's the second example, right? If you know the speed, and if you know the distance, if you know the speed, right? Speed is 500 kilometers per hour. Then you can figure out the time. The time, okay, is going to be the distance divided by speed. Okay, look at the formula, right? So it's 2,000 divided by 100, so you get 4. So it takes 4 hours to travel from one point to another point. Okay. So this is a formula used. Okay, only you when you use this formula can solve the problem. Okay, don't every time when you compute the speed, you have to use a formula. Okay, this is the formula again. Okay, so let's take a look at the first example. And here's a problem. Okay, the distance between point A and B is 220 kilometers. So we have to draw the picture, okay? David walks at the speed of 6 kilometers per hour. John walks at the speed of 4 kilometers per hour. At A 8 o'clock a.m., David left A toward the B, and John left B toward the A. When will they meet? Okay, so this is a yeah, you have to draw the picture when you do the homework, right? So John going the David going this way. So this is a David, right? And this is a John. Okay. John left B toward the A. So this is John. And this is David. So you draw the picture, okay? And David is faster than John, right? David is 6 miles per hour. 6 miles. Okay, so let's take a look at this. The question is when they meet. So you have to find out how much time right, it takes for them to meet. Okay. Now, yeah, we can find the time. Yeah, it takes how many hours for them to meet, okay? Now, there are a couple ways to solve this problem, okay? We can, yeah, let me give you one. We can also use equations, or we can solve the problem without equations, okay? So think about total 20 kilometers. When both start to walk, right? And then the distance is shrinking between those two, right? Right, at the constant rate, okay? So actually it's combined rate. It's a 6 kilometers per hour and 4 kilometers per hour. So every time, you know, this is the combined speed actually is a 6 plus 4 kilometers per hour, right? 6 plus 4 kilometers per hour, okay? And that is 10 kilometers per hour, okay? So the distance both travel together, okay? The combined speed S is going to be 6 plus 4, 10 kilometers per hour, okay? And then takes how much time the total combined travel 20, right? So the time T is going to be 20 divided by the speed, right? So this is the distance divided by S, right? So it's going to be 2. So it takes 2 hours, both travels together, right? 20 kilometers. So that's why then that you meet. Now, if you think about that way, and then you find the time, it takes 2 hours. So you can say at 10 o'clock a.m. they meet. Another way to do is they're supposed to meet somewhere here, right? So you let a t to be the time it takes. Yeah, you assume that it takes t hours to meet, okay? Okay, at some point on the way. So for David, right, it travels 6 times t. That is the distance because there is a speed is 6 kilometers per hour, right? So it will be, yeah, this is a picture. So for David, it's 6 times t. For John, the speed is 4 kilometers per hour, so 4 times t. That's a John, right? Total, because I meet at some point, the total distance combined, right, it will be 20 kilometers. So that is, you set up equation, okay? So 60 represents the distance David traveled, 40 represents the distance John travels, and they meet at the point, so it means the sum of the distance they travel is going to be the total distance, which is 20, okay? And why 6 times t? Because the speed times time gives the distance. Okay, so that's why 10t equals 20, and the t equals 20 divided by 10, and you get 2. That's a 2 hours. Okay, so that is how do we solve the problem using equations. Good job, kid. Okay. All right, so second one, so here's the second problem. It's a similar problem, and I wanted to do it, okay? And this is a car A and car B run toward each other from town A and B. And car A speed is 65 miles per hour, car B speed is 55 miles per hour. If two cars will meet, okay, this time the time is given. What is the distance between town A and B? Okay. So you don't know the distance between A and B. But we know that this is a speed, right? 65 miles per hour. That's a speed 55 miles per hour. So in what is time? Okay, in 3 hours. In 3 hours, they meet. They will meet. Okay, so we want to find out the distance between A and B. Okay, can you do that? You know, how do you find the distance? Like if for one single car, right? When it travels, you know the speed, you know the time, right? Remember, the formula you need is a distance equals speed times time. Okay. So the total distance, so the distance between A and B, right, is the sum of the distance between C, right? This is the place where they meet, and the distance between C and B. So we have actually the distance, right, between A and B. Okay, this is going to be, first of all, 3 hours. The car A travels this distance, right? And the car B travels this distance, then add them together. Okay, but here's a tricky, you don't need to do 65 times 3 then plus. There's a common factor here. So for the common factor, you should do this addition first. Then you don't need to do 2 multiplications. So 65 times plus 55, right? It's going to be 120. So then times 3, it's easy to compute as 360. Okay, that is in mileage. Okay. Then multiplication is more complicated than addition, so that's why I do addition first, if possible. Okay, good. So the third problem, this is we know the distance between seat A and the B. Okay, this is A and the B. Okay. A person A and the B walks away from A and also walks away from B in the opposite direction. But the person A walks twice as fast as B in 3 hours. the distance between person A and the B is 56 kilometers. Find their speed. Well, if you know the speed of the person A, then you can get the speed of the person B. Okay? Right? Because the person B doubles the speed. So that's my hint. Their combined speed is going to be 3 times the speed of B, right? Yeah, how do you solve this problem? Yeah, think about. So Michael got his answers. We can do a couple ways to solve the problem. Okay, you see, you can draw the picture like that to double the speed. So you have this, right? So this additional distance that travels total will be 56 minus 20, right? And that is a 36. So 36. But look at the picture. On the left side, you have 2 sections. On the right side, I have 1 section because the speed, person A's speed is double the person B's speed. So 1 section, so the person B's speed is going to be 36 divided by 3, right? So that is going to be 12 kilometers per hour. Okay, so that's it. Then right? Oh, sorry. So in 3 hours, yeah. It's not a. The combined speed. So both, right? So we know the distance, addition distance. This addition is increased in 3 hours. So the combined speed, okay, is 12 hours per 12 kilometers per hour. Because in 3 hours it increased, right? 36 kilometers. Then you have to divide by 3 because person A's speed is double the person B's speed. Okay, then person B's speed should be equal to 12 divided by 3. Okay, that is going to be 4 kilometers per hour. Okay, and then you can find the person A's speed, okay, which is double of this. Two times 4, 8 kilometers per hour. Now, if you don't want to, if you do not want to use this kind of picture to solve problem, just want to use equations. How do you do that? Well, the speed for A we denote by A. Okay, A is going to be person A's speed. Okay, B is a person B's speed. Okay, so those are 2 unknowns. But first we know that A equals 2B because A double, right? Then what I can do is you try to calculate the distance in 3 hours. In 3 hours, the distance the person A travels would be 3 times A. The distance person B travels is going to be 3B times 3b, right? Because time times the speed. Then add the 20th, right? This is going to be the total distance, 56. So you needed to solve those two equations. But the second equation can be simplified because this 3a plus b, equals 36, right? Combine them, right? And then you divide by both sides by 3, then you're going to 12. So a plus b is 12. A is going to be, then you replace a by 2b, then you get 3b equals 12, then b equals 4, okay? Then a equals 2b, so 2 times 4, which is 8. That is yeah. So as long as at the very beginning you set up the correct equations, then remaining part is just algebra, just solve it, okay? So you even don't need to think about, this is equivalent to that or something, okay? Otherwise, you have to think, oh, the increased distance is 36, and then this it takes 3 hours to increase this distance, right? So then the 12 hours per kilometers, but this contributed by 2 person, right? Then one has faster speed than the other. So you have to divide by 3, so in order to get a person bit speed. This is the way how do we think at the very beginning. And that's okay, but this usually can be, the method we use on the left-hand side usually only for simple problems, specific problems. When the problems are getting more complicated, you needed to use the equations to solve. Okay? So I hope you solve a problem using both methods. All right, let's understand this problem. The question is a little bit long, but be patient to read it. David and John walk toward each other from A and B, respectively. The distance between A and B is already know that, 2,000 kilometers. Right, 2,000 kilometers. This is a A. Right, that's a person B. Oh no, that's a point B. Okay, this is a David, right? And the John. Right. And you know the distance between them, 2,000 meters. David and John's speed is at 110 meters per minute, 90 meters per minute. Okay. A dog will start to run from point A and make a U-turn when it meets John. Aha. Then make a U-turn again when it meets David. Until David and John meet, dog speed is 500 meters per minute. What is the distance that the dog travels? So what does that mean? Okay. The dog will start to run from point A. Okay. The dog will start from point A. Okay. Dog speed is slower than David, right? Dog, oh no, fast. Yeah, fast. 500 meters per hour. So the dog is going like fast. David going this way. Then the dog from A, and that's right. So we make a U-turn when dog see John, and then go back to see David. Then when to meet David, the dog, okay, then make a U-turn again. Okay, just keep it going between them. Okay, until the both meet the dog stay there. That sound happens, right? Okay, and how do we solve this problem? All right, so this sounds a little bit tricky, right? All you need to do is how much time, okay? How much time it takes a dog, okay, to stop. Well, the time for the dog to stop is going to be the time when David and John meet, right? When the David and John meet. So, right? So if you know that, then you can solve the problem quickly. Right? Let me repeat again. The time it takes for the dog to stop, right? Because the dog starts to run. And the faster first was then David. Then meets John, then come back to see David, and then again go back to John, then go back to David, right? So many times. Yeah. But this you need to know the time for the dog to stop. That's how much time, right? Okay. But that is a time when David, right, and John meet. So we have to find the time. Right? Time, right, is actually t is going to be 2000 divided by David's speed divided by John's speed. Either John's speed. That's combined speed, and then this gives you 10. So that means in 10 minutes, David and John meet somewhere here. Okay, in 10 minutes, right? So you have to look at the combined speed, okay? And then in 10 minutes, okay, then total they traveled 2,000 meters. So that is the time for the dog running, and then dog will stop in 10 minutes. So that's why the distance, okay, the dog travels, okay, D is going to be, use that time you get from John and David, right? 500 times 10, so it's a 5,000. 5,000 meters, okay? That's it. Okay, so you use some other information to calculate the time, and that time then apply to the dog, a different object. But you cannot figure the time. Yeah, you cannot figure out the time directly. Now, this is another problem. It's also a little bit tricky here. This is a runway, elliptical runway, okay? And this is our starting point. David runs that way, and John runs that way, right? They are started to run at the same point in the opposite direction. But after 4 minutes, they meet at the first time, 4 minutes late. Then, if it takes total 6 minutes for David to complete the loop, how long it will take John to complete one loop? Wow. Okay. Think about that. Okay. For David, it takes 6 minutes total. 6 minutes. Okay. And how much time it will take for John to complete the loop? We don't know the distance of the loop. Okay. We don't know the length of the loop. But you have to think about it separately, right? One loop is from here, right? This is a David, right? This is a David. And then, and this is going to be the John. Okay. For David, it takes 6 minutes. Then for John, we don't know. Okay. But in order to figure out John's time, if you know the same distance, right, that travels, if you know the relationship between the speed, then you can solve the problem. Okay, let me give you this hint. So think about that. Okay. I have one person without a name on that. Would you please tell me who you are? Sounds like Michael Lee, right? You guys. All right. So in order to find the relation between John's speed and David's speed, you have to use the other given information. Okay. The other given information is after 6 minutes, right? They meet. So John, okay, look at David, right? For yeah. So let me draw the picture. 6 minutes, David is here. Right? Right. So this is this is 4 minutes for David. The total for David travels 6 for this, right? For David is 6 minutes. So David continue 2 minutes. Right? 2 minutes. David completed the whole loop. Right? So that means the distance David traveled in 4 minutes doubles the distance John travels. Okay, that means David's speed is right. It doubles John's speed. Right? So that implies David's speed is going to be twice of John's speed. Right? If you know that, then John's slower than David. So if you take David for 6 minutes to complete the loop, and it takes John's 12 minutes to complete the loop. Okay. Okay. So it takes 6 times 2, 12 minutes for John to complete the loop. Okay. Okay. So you know John's is slower. It's a half of the speed of David. Okay. So that's why you need a double time. Okay. Okay, got it? Yeah, this is the idea. So you need to figure out the relation between the speed. That's all you need. You don't need to know how long of the loop. But you can also solve this problem using equations. If the problem becomes complicated, then you have to use the equations. For example, you just change it after 4 hours, right? After 4 minutes, they meet the first time. If it takes 5 minutes for David to complete the whole loop, then the problem is going to be more complicated if you do like that without using equations. Okay, but I'm not going to use equation here to change the problem. Let's move on to the next problem. Yeah, sometimes I just show you, it's better to use the equations to solve. David rides a motorcycle and John rides a bike. At the same time, David and John start to travel toward each other from a village A and a village B. They meet in 5 hours. Okay, let's draw the picture. Here's A and here's B. So they meet here, going in that direction. Okay, so they're meeting 5 hours. Now, if it takes 15 hours for David to travel from A to B, how long will it take John to travel from B to A? This problem is similar to the previous problem, okay? But we don't know the speed, John David's speed and John's speed. We don't know the distance between A and B. Okay? But can you figure out the relationship of that speed? Okay? Yeah. So David's speed, right? This is a David, right? David's speed, okay, let's say use a D. John's speed, this is a John. That's a David. Okay. David and John start travel from A to B. Okay, their meeting is 5 hours, right? Yeah, this is a John. Okay. Oh, Michael, good. Okay. So let's find the relationship between their speed. Now, they are meeting in 5 hours, but if David continue travels for David going from that way, okay? So 5 hours is here, right? 5 hours. Then he has to travel additional 10 hours, right? It's just 10 hours, right? Right? So for this distance, right? John only takes 5 hours, but David takes 10 hours to travel. So that means John and David's speed is half of the John's speed, or John's speed is double the David's speed. Okay, just look at the distance. We don't know how long it is, right? They meet at the point C. They meet at the point C somewhere, right? That's the point they meet. Right? Yeah, my picture does not reflect that, but that's okay. You know, I can modify. Actually, yeah, this should be somewhere here. Okay, this is point C. They're where they meet. Okay, right, somewhere they meet here. Okay. We don't know the distance between A and B. We don't know the distance between C and B. But for David, it takes, he has 5 hours, then continue 10 hours, right? This is the picture. So for that section, it takes 10 hours for David travels, but it only takes 5 hours for John. So that means John's speed is double the David's speed. Okay, it's twice David's speed. Okay, so that is all you need to know. Then you can figure out. And then you can figure out of how much time it takes for John to complete, right, from A B to A, because right, so because John's speed is fast, right? It's twice of David's speed. It takes 15 hours for David travel from A to B. Then it will only take half of the time for John to travel from B to A. Okay, so the time for John should be equal to 15 divided by 2, 7.5, right, hour. That is how do we do the problem. Okay. If you know the relationship between their speed, then then you can figure out how much time it takes for John. Okay. Now, if you want to use the equation, how do you solve the problem? What kind of equation you can set up and solve it? So let's try this, okay? You don't know the distance. You can assume the distance between A and B is going to be D, okay? So D is the total distance, for example, between A and B. And you can say D, we don't know, D miles, right? But this will be canceled out. So 5 hours, right? 5 hours, 5 times David's speed plus 5 times John's speed. Total, this is the travel, it's going to be D, right? Yeah, right? Then it takes David 15 hours to travel. So 15 hours for the David, it travels D, okay? So you needed to figure it out, right? So that is equations. Okay, so you have two equations, and then you find you can assume D equals 1 to make it easy, okay? Or you can assume D equals 15. It's not a big a deal. Eventually they cancel out. But you keep that, right? If you keep that, then I can multiply the first equation by 3, okay? So make it, right? First equation minus 3, okay? Okay, so you have a 15SD plus 15SJ equals 15D. So now 15SD is just D, right? Sorry. 15 hours. Oh no, it's a 3, so it's not that. That's a 3. Okay, so that's the D, right? Because 15D and the plus 15SJ equals 3D, then 15SJ equals 2D, okay? That's a relationship, okay? So now you want to find the time for John to complete from B to A. So that's the time for John is going to be D divided by SJ, okay? But from above the equation, D divided by SJ is going to be 15 divided by 2. So it still gets the same answer, okay? So that's using the equations. Well, for complicated problems, maybe easier for equation, but if it's up to you whether you want to try and use the equations, okay? So let's move on to the next problem, okay? Aaron, please don't type anything. The micro stop. Okay, so let's work on the next problem. The distance between A and B is 458 kilometers. The car runs a speed of 46 kilometers per hour. Car B runs a speed of 38 kilometers per hour. Car A and B leave the city at a different time, okay, different time. So car A has traveled 30 kilometers when they meet. How many hours earlier did the car B leave city B? 1. All right, so you have to draw the picture again. This is the A and that's the B. Okay. Right? So their total distance of 458 kilometers. Okay, but we know the speed. Right, we know their speed. This is speed, 46 kilometers per hour. That's the speed of 38 kilometers per hour. So first, we have to figure it out, the car A and the B, they leave at different time, okay? But the car A has, when they meet, okay, when they meet, the car A traveled 230 kilometers. So you can figure out the time, okay? You can figure out the time for each, right? That's my hint. Okay, first of all, you have to figure out how much time it takes for the car A to meet car B. That's my hint. Because when they meet, car A already traveled, right? 230. Yeah. So first of all, you figured out for the car A, that's where they meet, right? For the car A. So the time for the car A, and this is the time, is going to be the distance it traveled and its speed. So this is 5 hours. Okay, when they meet, car A already traveled 5 hours. Okay, then you can also figure out the distance. This is 230 kilometers. And then because I meet, right? So the distance for the car B travels will be 228 kilometers. So why? Because 458 divided by minus 230, right? It's 8, it's 2 and 2. Okay. So we know the speed, we know the distance the car B travels. Then you can find out the time. 228 divided by 38 kilometers per hour. That's 6 hours. Okay, so it takes 6 hours for car B to travel such a distance. So they are meet. Okay, then clearly car B is 1 hour earlier than car A, right? Because then when meet at the same time, car B takes 6 hours, right? That's right, 1 hour. The answer is 1 hour. Okay, because it takes car B 6 hours to travel the distance, 228 kilometers. Right, and by that time, car A travels for 5 hours. That's why car B is 1 hour earlier. All right, so move on to next problem. All right, let's look at this. Again, you have to draw the picture, right? So distance between two cities, 553 kilometers. Okay, when is faster? Okay, this is a car is 90 kilometers per hour. Car B is 66 kilometers per hour. If car A, car B runs toward each other, car A has run for 230 kilometers when they meet. How many hours? So it's the same problem I wanted to work out. Okay.
Do cars leave the cities at the same time?
No, it says how many hours earlier did the car B leave city B. So there's a difference. We only know that when they meet, car A already traveled 230 kilometers. Right? We don't know. Yeah. We don't know whether they leave at the same time. We want to find out. Okay, this is a place they're meeting. Okay. That's all the information we have here. It's similar to the above problem. If you understand the above problem, you can solve this. Yeah, you need a calculate the probability that involve decimal point. But first of all, yeah, you figured out the time for the car A travels is 230 kilometers per hour. Okay, well, that's a 230 divided by 90. Okay, it's going to be you can divide. It's going to be 23 over 9. If we just keep a fraction, so I don't have a calculator. Okay, so then the distance traveled by car B is going to be, this distance is 534 minus 230, and that is 304, right? Kilometers. So the time, okay, the car B spent on the road is 304 divided by 60. Okay, so that is well, if you don't want to simplify, yeah, this is a number. But if you use a calculate, and this is a
66.
66. Yes. Okay. Yes. Yeah, I copied it wrong. Thank you. So if you use a calculator, it's 5.06, and this is a 2.55. Okay. 2.55, and then the difference is 5.06 minus 2.55 is 2.51. So this is a time difference, and clearly car B leaves earlier, right? And 2.51 hours earlier. Okay, 2.15 hours earlier. Okay, so that's it. And let's move on to next problem. So Dave and John walk together toward each other from 2 points, which the distance is going to be 2,300 kilometers. David's speed is going to be 100 kilometers per hour, and John's speed is 8 kilometers per hour. It's not walking, they're driving, okay. Kilometers per hour. Not walking, yeah. Run. Okay. So this is John. John has walked 960 meters when they meet, okay. So I want you to solve, it's a similar problem we did, right? So John, when they meet, this is 960 meters. So you can also figure out the distance where David travels. So the distance David traveled is going to be 1,400, right? Okay. All right, so now you can calculate the time, right? For David, okay, it takes 14 hours because 1,400 divided by 100, that's 14. And for John, right, it takes divided by 80, so it's 12 hours. So the difference is going to be 2 hours. Right, so the difference, right, is 2 hours. So that means that David, it takes, how many minutes is 120 minutes earlier did David? Okay, so the answer is 2 hours or equivalently as 120 minutes. All right, so let's finish this problem. I'm not going to do the last one. All right. So two airplanes fly toward each other from two airports at a distance 1,695 kilometers. Plane A left the airport 1 hour earlier. This time we know the difference of the time. Okay. Then plane B. Plane A's speed is 325 and plane B's speed is 360. How many hours after plane B left they will meet? Okay, so let's draw the picture. 1,695 kilometers. That's a A, right? That's a B. Right. Okay, can you solve this? I'll give you 1 minute to think about. So this left earlier, right? Left earlier. Right. So what we can do is first we want to find out in 1 hour where the plane A. So how much distance travel? So in 1 hour, right? The plane A flies 325 kilometers. So the remaining distance will be 1,695 minus 325. So it will be 1,370 kilometers. Then they both leave right at the same time. So the combined speed, so how much time it takes for them to meet, right, to travel this total distance. But so the time they meet, okay, in how many hours the time they meet? It's a 1,370. That's the total distance they travel. But the combined speed is, right, 325 plus 360. Right? Then after simplifying, you just get 2. Okay, that is the answer. Okay, in 2 hours, they will meet. Okay, in 2 hours, they will meet. In 2 hours, the airplane traveled total distance, 1,370. Okay. Right. So then you have to combine that speed because that's the total distance they traveled. Okay, in every hour, that is 350. 25 plus 360. Okay, that's all I want to discuss. Okay, you have to draw the picture, and for more complicated problems, you probably have to use equations. Most of them, we can use a picture and they can draw it, and you can solve the problem. Okay. Yeah, we never got to the 11th problems. I will copy the 11th problem to the homework assignment. So I hope you can figure it out by yourself. Okay, I prepared 11 problems. I didn't have time to finish it. Okay. See you.
再见，老师。